Right, welcome back. Let's do question 9.1. In the diagram below, O is the center of the circle. Points S, T, and R lie on the circle. Then QS is tangent to the circle at point S here. Right? Use the diagram alongside to prove that the angle between the tangent and the chord is equal to the angle in the alternate segment. Right, this is the angle between the tangent and the chord, which is angle QST, and then this is the angle in the alternate segment, which is angle R. So now we need to prove that these two angles are equal. So we'll use the color red for those two. So when you're proving a theorem, like in this case we're proving the tan-chord theorem, we have to remember the theorems that we have to use. And then also we have to remember the construction. Actually, the construction is the one that we have to remember first. Right? What do we construct when you're proving the tan-chord theorem? We have to construct diameter from the point of contact of the chord and the tangent through the center and then to the circumference. That is diameter. Okay? Let's call this point K. That's the construction you have to do. And then the theorems that you're going to use, we have angles in the same segment, right? We're going to use that. And then also angle in semicircle, that is angle subtended by diameter. Angle in semicircle, that is angle subtended by diameter. We're also going to use the tangent perpendicular to radius, or you can say tangent perpendicular to diameter, right? Okay, and then now what we construct, we'll construct KR here, join these two so that we form angles in the same segment. So we have this angle and then we have this angle. These are angles in the same segment. If you check, they are subtended by TK, right? We have this angle there. You see that? Subtended by TK. So angle TSK is subtended by TK. And then we have angle TRK subtended by TK there. You see that? So these two angles are equal because they are subtended by the same arc or subtended by the same chord. We say angles in the same segment. Right. So now what do? We have which angle? We have angle KRS. What is angle K? What is the size of angle KRS? Right, angle KRS is equal to 90 degrees. And then what's the reason? Angle in semicircle. And then we have this angle QSK. We have angle QSK. What is angle QSK? Right, angle QSK is equal to 90 degrees also. This is the tangent perpendicular to radius. Tangent perpendicular to radius, or you say tangent perpendicular to diameter. So these two angles are equal, but also we talked about angle TSK and angle TRK. But what about the right angles? How can you find right angles from what we have here? Right, angle QST. Angle QST is equal to 90 degrees minus angle TSK, right? Isn't it? To find the right angle here, we can subtract this blue angle here, TSK, from 90 degrees, isn't it? Right? And then also this side, angle R. Let's use angle R. You can also say TRS, but let's use R because here we're using angle R. So angle R is equal to 90 degrees minus this blue angle here, which is TRK. TRK, right? And then, but if we check, we are saying that angle TSK is equal to angle TRK. Okay, isn't it? Because these are angles in the same segment. We talked about that. Angles in the same segment. If these two are equal, what does that mean? We have 90 minus TSK, we have 90 minus TRK, but these two are equal. So we can say, therefore, angle QST is equal to angle R, right? Because 90 minus TSK, 90 minus TRK, and then these two are equal, isn't it? So it means angle QST is equal to angle R.